Hey everyone, so just like last time, I want to do a few more practice questions with the angular projectiles. In particular, I want to try to focus on some of the more complex questions. So first one is this one. So pause the video, work itself, and we'll go over in a second. All right, now we pretty much do the same steps that we've done before. We make up our XY chart. So we break up all the information here. Once again, they give us this initial velocity and this angle. So I'm going to immediately break up and do 21 cosine 40 to find the 16.1 and 21 sine 40 to find 21 meters per second. They give us the final position of the goalpost. It's 36.6 meters away. However, one thing to keep in mind is that this number is not going to be plugged into my XY chart because this is what's called a reference number. They're just telling us that the crossbar is 3.05 meters above the ground, but it doesn't necessarily mean that the football gets to that height. It actually asks later on, is this a successful field goal? So what they really want us to do is compare that final position to this 3.05 to see if it makes it over. So for the most part, our chart ends up being pretty much the same. It wants us to figure out what the time in the air is. So if we look here, we notice that we actually have a lot of information in the x direction. So I'm going to start off using the annoying x in the x direction. So I plug all the numbers in, and I end up getting 2.27 seconds. So the ball is going to be in the air for 2.27 seconds. With that, I can then remake my chart. I now have enough information to figure out what this final y value is. So I use the knowing x again for the y values this time, and I figure out that the final y position is 21.9 meters in the air. Now, that's not my final answer. The question is this a successful field goal? So looking back at my reference number, 3.05, yes, this number is above 3.05, so it clears it. Now, obviously, these numbers seem to be very insane because normally the ball wouldn't get that much higher than the crossbar, or I guess not for this type of setup. All right, here's the next question. Pause the video, work itself, and we'll go over in a second. All right. Now, at first, this might seem like a really difficult question to the point where you can't answer it because there's too many unknowns. However, one thing to keep in mind is that when we set up our chart, uh, we can actually combine, we don't know what the initial velocity is in either x or y direction because I don't know what velocity this cliff diver is jumping off with. But I don't need to worry about that because I can actually combine them together to make one unknown. So instead of having just, Vx and Vy and saying I don't know what they are, well, I do know that Vx is uh, V naught cosine 40 and Vy is V naught sine 40. So now I basically have the same V naught on both sides. I can use this information to basically figure out what I'm looking for. I'm looking for the final position. I forgot to put that in here. So using this, I can actually use the Y side and plug this in. It's a little bit weird doing this, but it is something that you might see on the AP, so it's important to kind of be aware of this. And that's actually why I want to go over these questions because I don't always ask these types of things in class. So when we plug into the numbers, we have the V naught over here. Uh, we move some things around and we get that the initial velocity is 0.78 meters per second. With that, I now know what these two values are. So I now know the initial velocity in the x and y. I didn't plug it in, uh, but I can plug it into the annoying x to find where the final x position is. Now that I now have all the information. So plugging that in, the velocity I got before, and I end up getting that he lands 1.49 meters away from the cliff. All right. Here's the next question. Pause the video, work itself, and we'll go over in a second. All right, now this is essentially the exact same problem from before with the slight difference of how we get that initial velocity. Last time we used the time in the air to figure out what that initial velocity was, but this time I'm going to use the fact that they say maximum height. So I do the same trick before where instead of writing Vx and Vy, I use V naught cosine 50 and V naught sine 50. Honestly, my recommendation is I would even get rid of the cosine 50 and sine 50 because that's annoying. I would actually plug that in as 0.64 times V naught or 0.64x. for this one, and then this one would be um, 0.77 V naught or 0.77x. Just because it's you want to kind of use when you have numbers that you can calculate, you want to kind of keep things in decimals. Keeping things in sines and cosines can get a little tricky, you know, or annoying to deal with, and kind of bogs down the whole work. So it makes it nice and cleaner to just get rid of the cosine and sine and plug in what they actually are from the calculator. But that's just my recommendation. You don't have to go with that. But like I said, based off of this information, I can use the maximum height and the fact that in the vertical direction, the max height, the velocity ends up being 0 at max height to figure out what this initial velocity was. So I get that the initial velocity was 2.26 meters per second. And that's actually it. That's all I need to worry about. All right. Now, this is the last question, and it is probably one of the more tricky problems. So pause the video, work yourself, and we'll go over it in a second. Now, like I said, this one's really tricky because before I can actually fill out the XY chart, I actually need to figure out where the ball is being thrown. They tell us that the basketball player is 1.8 meters tall. We're told that the ball is being thrown from the top of his head, but he also jumps straight up into the air. So the height that the ball ends up being thrown at in the beginning is not the 1.8, it's something else. So this is actually two problems in one. So I have to do a side problem first before I can move on to the main problem. The question is, how high does he go up in the air in order to figure out where the ball is being thrown? So based off of this information, again, I'm ignoring everything else. All I care about is that he's 1.8 meters tall, and I care that he's jumping with an initial velocity of 2 meters per second, and he reaches some maximum height. So using that information, I know that his velocity when he reaches the max height is 0, his initial velocity is 2, using knowing x, and we find that he jumps up a total distance of 0.2 meters. Now this, combined with his height of 1.8 meters and the fact that it's being thrown from the top of his head, means that the ball was shot from a height of 2 meters. Now, once I have that 2 meters, I can now continue on with the rest of the problem. Now I know that the initial velocity uh, is 10 and the angle is 80, so I can get that the velocity in the x is 1.74 and that the velocity in the y is 9.85. I know what the final position of the ball is. It's 4 meters. And everything else is pretty much standard. I'm looking for this final position. So just like usual, I can't find anything in this x column because I don't have the time. So let's look at the y column. Using the y column, I plug in my information, and you might find that something's interesting. I have two times, one with a time that's squared and one that's a normal time. How am I supposed to deal with this? You have one of two ways. You can plug into the calculator and figure out where, like plug in this equation to the calculator and see at what points these two parts cross. Or you can do a quadratic equation, negative b plus or minus square root of b squared minus 4ac all over 2a. Find the two times and you end up getting this. So you end up getting 0.277 and 0.76 seconds as the two possible times. I didn't show the Pythagorean theorem, the quadratic formula, because I just don't have the space on it on here. But if you're confused, feel free to ask me and I'll answer that question. But we have these two times, so which one is the time? Well, the reason why we have two times first is the fact that as the ball gets thrown up, it reaches this height twice. It reaches on its way up to the maximum height, and then as it comes back down from the maximum height. So the question is, which time am I looking for? Well, if we look back to the question, it gives us this piece of information that might not have seemed important at the time. The ball goes into the air, hits its max height, and then is coming down. So it's going into the net on its way down, which means we're looking for the second time. The second time it's reaching 4 meters in the air. So we use the time of 0.76 seconds, plug that in into the annoying x again, and we end up getting 1.32 meters. And that's it. Like I said, these were some of the more complex angular projectiles. If you're, it's not even really a big problem. Usually, a lot of angular projectiles in the AP tends to focus more on things like the factors that might affect angular projectiles. They a lot of times they're usually more standard. They're kind of almost slight extensions of the regions questions. So I wouldn't expect to see a lot of these questions on the test. However, if you did see a question like this on the test, it would be broken down in much more straightforward steps. For example, one step would have said, "What is the maximum height that the basketball player reaches?" So it would have kind of walked you through finding this information. Like, and then the next one would be, "What time? How long is it in the air? What's the time in the air?" So just be aware of this. That these were just more some of the complex questions just in case you might see them, but you should consider these to be uncommon to rare, especially this last one. If you have any other questions, feel free to let me know. Otherwise, good luck and have a great day.